This is a short presentation about an ongoing project. The project title is ToolSense, Sensor-Based Smart Tooling for Machining Process Online Measurement and Monitoring. My name is Vladimir Pushla, and I am from Lund University, and in this project, I am coordinating the activities of academic partners. The project is administered by Smart Advanced Manufacturing Program. In the presentation, I will focus on three aspects. One, brief information about the project itself. As two, our experience of proposal writing and application procedures. And finally, what our progress is as of now. The objectives of the ToolSense project have been set to develop, upscale, and commercialize smart cutting tools capable of online measurement and monitoring of forces, vibrations, acoustic emission, and temperatures in a machining process. Moreover, these tools are to be validated and implemented within the existing value chain of manufacturing advanced hydraulic and aeronautic components. To achieve this objective, we have assembled a team of tool makers, component manufacturers, and academic partners, each with their own complementary expertise. We have selected the project duration to be 3 years, as we foresee a long journey from existing laboratory solution to a full-scale industrial implementation. The total project budget is 1.6 million euro, which includes both the direct funding and in-kind contributions according to respective national rules. 3 nations are involved in the implementation. In Sweden, Seco Tools is the coordinating partner and the Smart Tool Integrator company. We have 2 SME companies, Purma Group Sweden and Akosvenska, who represent hydraulic component manufacturing and coolant lubrication solutions. Lund University is the academic support on thermal sensors. In Canada, Rainhouse Manufacturing is a validation partner for aerospace components, and National Research Council is the academic support on force and acoustic emission sensors. In the UK, Element 6 is the tool material designer, and Seco Aerospace Innovation Hub is the machining process developer. Now a bit about the application process. It was relatively easy to formulate the concept and consortium because we had an excellent alignment of the industrial need and the desire of the regional sensor developers to give life to their ideas. Extra ease was that as sensor developers, we have all worked with Seco Tools before and had a trusted relationship. And of course, attracting validation partners, most of whom are SME, was easy because building such complex system with their own resources is not affordable, and so joining a larger consortium was a natural step for them. When it comes to the application process and labeling, it was also easy because the rules are quite transparent. Especially helpful was careful reading of smart program documents such as Smart Technology Roadmap and Smart Evaluation Procedures. These were excellent guidelines of what the expectations from the program are, and this led us to focus on the essentials. Unfortunately, we were less careful with the rules defined by each National Funding Agency or NFA. These rules are very different from each country, and we nearly made critical mistakes and had to concentrate to solve them after leveling. A few tips. We have had a series of meetings on commercialization and exploitation quite early in the application process, and this helped us to clarify who has the intellectual property. And this eventually created a trustful and productive atmosphere. As mentioned, eligibility and funding rules for each nation are very different, and it's easy to make mistakes. And final, once receiving a label, you will have to apply on the national level. This application is not aligned among the participating countries. For instance, such application deadline is June in Sweden and November in Canada. Because of that, we overpromised an early project start and had to apply for corrections. Our project has been running for 7 months now. We have 5 major ongoing activities. It is the benchmarking of the industrial process we want to monitor later. This is done both individually at laboratories with commercial sensors and devices, but also at the industries. Our team now works on 3 sensors and their adaptation to become robust and scalable. And we work with signal transmission, which turned out to be not an easy task for such multi-sensory solution. All work is practically on schedule, but COVID indeed affected some of the steps, but no permanent damage has been done yet. And on the positive side, we have a major breakthrough with 4 sensors which already reached the set key performance indicators. To sum it up, on a scale from individual sensors to their fusion, to validation, and to economics, we are on step 2. Thank you for your attention.